Good morning, sir.
Good morning, Bhanu. Good morning, everyone.
Good morning.
We'll wait for a few minutes and then we'll get started. Bhanu, in the meantime, can you have your Proxmox, Linux, and Windows VMs up and running?
Okay.
Good morning, everyone. We will just wait for 1 or 2 minutes more and then we'll get started. Okay, let's get started. So yesterday we have seen how to successfully install Proxmox hypervisor on a machine. Okay. So today what we will do is we will briefly show you how the GUI or the management interface of Proxmox looks like, and then we'll start getting into some advanced operations of Linux which are generally used in day-to-day life of a data center engineer. Okay, so we will perform certain activities as we were doing yesterday. These are some real-world things that we do, and to troubleshoot and to perform certain tasks. So we will be doing more of them today and in the upcoming classes. In the meanwhile, don't forget about the test that is going to happen this weekend. Please do focus on that as well and spend some time on it so that you are well prepared. Okay. All right. So I'll request Bhanu to share his screen. So he has all the VMs and setup ready. Bhanu?
Yes. Can you see my screen, sir?
Yes. Yeah. So Bhanu, will you be able to zoom in?
Mm, so, mhm.
Is everyone?
Is it fine, sir?
Yes, this is better.
Oh,
Is everybody able to see the command line?
yes.
Okay, okay. Thanks. All right. So we saw yesterday that once we install Proxmox, the way we can access the GUI is use the IP address in the browser :8006. 8006 is the TCP port on which the Proxmox GUI services would be running, and that's how we can start using this Proxmox hypervisor. So, Manu, can you open a browser window and type the IP address :8006 with HTTPS? Correct. Then this is the login screen. In the login screen, you have to mention root and the password that we had used to do it while the password that we had used during the installation. Okay. Once you enter the right password, you can see this kind of a screen. Okay. I will just give you a very high level detail of what are the things that are available and what you see on the screen. Manu, can you reduce the left hand side panel a little bit? Yes. So, the way any virtual environment is categorized is we will have a high level entity called as data center. That is what you see in the left hand side panel. Manu, can you put your mouse around it? Yes. So you see on the left hand side panel, data center. Okay. So data center is the high level logical construct. Okay. So what does that logical construct have? That is telling us that how many physical machines, okay, how many physical machines are part of this virtual cluster. Okay, how many physical machines are part of this virtual cluster? In our lab currently, we have only one physical machine, okay, or one machine under this, and hence it is showing only one with the name test. But in a real world scenario, you will see multiple physical machines under the data center. Okay, now can you expand that machine, physical machine test? Yes. Now, when you expand it, then you will be able to see more details about each physical machine under the data center. Okay, like what is the name, what is the CPU memory, what is the storage, okay, all of these things. And that is what you see in the right hand side panel now. Okay, once you select anything on the left hand side, its detail will be shown in the right hand side panel. Okay, what is the CPU, what is the disk, okay, and everything. Now we will get into the details of this later. Okay, this is just showing a high level view for you. Okay, but before we get into this, we need to become better at running Linux commands, okay, doing troubleshooting and things like that. All right. And then you also see various other options like cluster, Ceph, storage, backup, replication, permissions, and all of these. Okay. So these are the GUI way of managing and configuring the physical machine and its attributes. Okay. And there will also be a CLI way, command line way. Okay. And I would actually recommend that you become better at using the command line more than the GUI. Okay. The more you use command line, the better you will be in managing a data center. Trust me on this. Okay. Most advanced configurations of machines in the data center is done through command line, not through GUI. Okay, GUI is for beginners. Okay, it is only to make it easier, but it does not have all the options also most of the time. Okay, so I recommend that you practice command line more than GUI. Okay, then on the right hand side top, you will see certain buttons called documentation, create VM, create CT means container, and then which user has logged in. Just follow the mouse pointer. Okay, documentation is nothing but the link which we used to follow the various steps, right? So click on that. So this is the documentation. Okay, so you see the admin guide and then the individual chapters. So click on the HTML version, online HTML version. Yes, and this is what you will find. So on the left hand side, you see the table of contents. Okay, you see all the various features and how to use it and the documentation around it. Okay, it's pretty exhaustive. Okay, but don't get worried. Don't get worried by seeing this. Oh, I have to study all this. No, you don't have to study all this. You have to understand that anyone in the IT industry can never become an expert in everything. It is humanly not possible. But if you know where to look for specific information, okay, whenever you are getting stuck while doing any activity, you can quickly come and refer to only that portion of the documentation. Okay, you don't have to read everything like how we do in colleges. Like a textbook is given, chapter 1, chapter 2, chapter 3, you keep on reading, right? No, you don't have to do that. Okay, understand where the documentation is as and when you are doing activities. If you are getting stuck, if you are unable to understand or you want to know more, just come to that part in the documentation and learn about it. Okay, very simple. Now I will just show you the high level architecture of Proxmox, and then we will get into our Linux commands, the a little bit more advanced activities. Okay. All right. So, Bhanu, on the right hand side pane, can you scroll a little bit? Yes, just keep this diagram. Right. So, whenever you see an architecture diagram in a data center, you have to look at that architecture diagram from bottom first. Okay. You have to see what is the base or the foundation or the bottom layer, and then slowly start understanding what is there on top of it. Okay. So you have to always see these diagrams bottom first. Okay. Look at what is there in the bottom. When we see this diagram of a Proxmox virtual environment, you will see that the base is a Linux kernel, right? As we have seen yesterday and the day before during our Proxmox implementation, that the Proxmox entire virtual environment is built on a version called Debian Linux, right? Debian Linux. And that Debian Linux forms the base kernel of Proxmox. Okay. We already understood in our previous classes that what exactly is a kernel, right? A kernel is the core of the operating system where it allows the operating system to interact with the hardware, and it forms the layer of interaction between all the other software modules on top of it to the hardware layer below it. Okay. So in this case, we have the Debian Linux kernel in Proxmox. Now this kernel, Debian Linux kernel, along with the Proxmox, packages, has got the ability to do two to three different things. Okay, broadly. The first thing is, of course, use that entire physical machine as a bare metal Unix machine. Okay. And you can start installing packages, you can start installing software, and you can start using it. Okay. So using that particular physical machine as a bare metal standalone machine, you can do that. Okay. Second thing that you can do is you can create a cluster. Okay. You can create a cluster. And this is very important concept. Okay. What is a cluster? A cluster is a logical grouping or a combination of multiple physical machines pooling their resources together to form a larger logical machine or a larger combined machine. Okay, that's called a cluster. So this particular Linux kernel with Proxmox packages on top of it will help you to join more than one physical machine, okay, and together, okay, in the same network to create a pool of resources which you can use. Okay, that's another important concept. And the third important concept is, once you create a cluster or even on a standalone machine, this Proxmox kernel allows you to create virtual environments on top of these base physical machine, either standalone machine or a cluster. Okay. And these virtual environments can be of two categories. First category is called as a full blown virtual machine, and the second category is called as a container. Okay. Two categories. One is a virtual machine and second is a container. All right. Now, let me briefly explain to you what is the difference between both of them. Okay. And you can see that in the diagram also. When you consider a virtual machine, you will find, okay, basically three different layers. What are those layers? From bottom to top, you find QEMU, which is nothing but a emulation. Okay. It's an emulation software. Okay. Which will abstract the CPU, the memory, the hard disk, the network, and all these hardware resources to the virtual machine. Okay, so that's the emulation, layer. Then inside a particular virtual machine, you will have another instance of a guest operating system. It's called a guest operating system. Okay, what is a guest operating system? nothing different from the operating systems that we know already. Okay, we have already seen this concept when we were doing Hyper-V installation, right? When we enabled Hyper-V on your Windows laptop and you created a virtual machine, the first thing that you did is identify which operating system you're going to install inside that virtual machine. Okay. So even though your base laptop is Windows 10 or Windows 11, once you created the virtual machine, you were able to install a Linux server class, okay, operating system inside it. Then you are able to create a Windows virtual machine. So there the guest operating system was Windows, but not Windows 10 or Windows 11, which is the base operating system on your base physical machine. When we created the VM, we actually created a Windows 2022 server class guest operating system inside the virtual machine, right? So that layer of the operating system which is residing inside the virtual machine is called as a guest operating system. Okay. And once you have created this virtual machine where you have the emulation layer and then the guest operating system installed inside the virtual machine, you can go ahead and start using that virtual machine to install your various applications and workloads on it, which we see as app there. Okay. Any questions or doubts on what exactly is a virtual machine? Any questions or doubts? No? Very simple. Okay. This is all something that we already have seen and we have understood. But now, what is a container? Okay. Here is where I'll go back a few steps and try to explain to you in basic simple language the use case of a container first and then what exactly it does. Okay. Now, in your engineering languages, curriculum or graduation curriculum, you all learned programming languages. Give me a thumbs up if you did. C, C++, Java, Python. Okay. All these programming languages you would have learned. Yes, great. Thank you, everyone. Now, how do you execute a program once you have written it? Can anybody tell me? How can you make the program that you have written executable?
To compare.
Yes, we use something called as a compiler, right? So whatever program you would have written, the Python script, the C program or C++ program or .NET program or Java program doesn't matter. Okay, whichever programming language you use doesn't matter. You need something called as a compiler. Okay. And what are the inputs that you give to a compiler when you are compiling a program? Can anybody tell me? What are the inputs you give to a compiler? Of course, one input is your program itself, the code that you have written. What else do you tell it? You tell it on which CPU architecture it should run, correct? You tell it whether it is x86, 32-bit or 64-bit. Yes or no? Give me a thumbs up, all of you. You give the architecture. Yes, right, correct. And then you also tell on which operating system you are going to execute this because the output of that compilation, okay, will not be the same if you want to run that program on Windows and Linux. Because on Windows, we have seen that any program has to be .exe or .msi, okay, to install and run, right? But in Linux and Unix, it's not that, right? It's called RPM packages, okay? So the output of the compiler from the program input that you have given to it will depend upon two to three parameters. First parameter is the underlying CPU architecture, right? Is it x86? Is it ARM? Okay, is it something else? Then is it 32-bit or is it 64-bit? And then what is the type of operating system? Is it a Windows-based operating system or is it a Unix-based operating system? Right? Samsivrav, do you have any question? You have raised your hand. No? Okay. So what exactly is the compiler doing now? Since you want to execute your code on an operating system, it is making this code into an executable form, and that's the role of the compiler. Correct? And whatever output comes out of the compiler in the form of an exe file, then you go ahead and install it on Windows and run it on Windows. If it is on Unix or Linux, it will be some kind of a shell script or it will be some kind of a package, right? And then you go ahead and run that package inside the Unix or Linux environment. So in one of your previous classes, we saw how to execute a shell script, right? Now, this scenario worked well for many decades in the data center space. Okay, but as and when the programs became very complicated, okay, as and when they became very resource hungry, okay, this methodology was not something that the new age programmers wanted because they were paying a huge penalty in terms of resources for the operating system layer. Okay. And we saw that when we are installing Linux, when we are installing Proxmox, when we are installing Windows, it takes up a lot of time, okay, to bring up that virtual machine. It takes up a lot of CPU resources. But was there an option with us? No, because that program we cannot run directly on the hardware. We need that operating system. There is no layer in between which can help us directly execute a program on the hardware. Okay, and that's why we essentially needed the operating system layer to help us to do that. But that's where the world changed. Just about 10 years back, okay, came the concepts of container. Okay, came the concept of container. Now, what exactly is a container? You see it in the diagram there. So in the blocks, in the gray color blocks that you see container, do you see any emulation layer? No. Do you see any guest operating system layer? No. That means what? Whatever application or programming language or code that you're writing in Python, in C, C++, Java, R, okay, doesn't matter, right? You can have the ability to directly execute that code without an operating system. Okay? Without an operating system, you can directly execute that code, which means, would you need a compiler then? If you can directly execute a code on a hardware, do you need a compiler?
No, sir.
Yes, that's the right answer. You don't need a compiler anymore. So do you need to install guest operating system like Linux or Windows or Unix? No, you don't need it. Okay. And can we bring up these containers very quickly? Does it need to do something called as a booting? No, there is no concept of booting anymore in containers. Okay. So this is the new age virtualization. Okay. This is the new age virtualization. Until about, I would say 6, 7, 8 years back, all the applications were written in such form that you necessarily needed a guest operating system to run that program or to run that application. But all the new age programs that we have, the apps that you're running in your mobile phone, right? Be it Amazon, be it Netflix, be it Flipkart, be it anything, okay? In the backend, when they're running in the data center, they are not running on virtual machines, okay? They are running on containers. And one of the most popular version of containers is Docker. Okay, all of you have heard this word Docker, right? And that is why today people who understand how to manage a container environment, okay, using Docker, using Kubernetes, okay, they are in very, very high demand because all the applications, okay, which were written ages back using these programming languages, then compiled into executables, they are all getting changed, okay. Even our core banking software, everything is getting changed to run on containers, okay. So we need to understand how to successfully use and manage virtual machines because there are still, I would say, 60 to 70% of the data center workload still running on virtual machines, okay. But all the new age applications, they are all running on containers, okay. And one beautiful thing about containers is it supports something called as auto scaling. Okay, it supports something called as auto scaling. Now, what exactly is auto scaling? As and when the load on that application increases, okay, let us say that uh, the best example that I can give is this big $1 billion sale that Amazon does, okay, or whenever we are seeing IPL matches or these T20 cricket matches, okay, you see on the top right hand side corner number of viewers, okay, we all keep seeing, oh, how many people are watching this match, okay, and especially if it's a critical match, we see the number of viewers just increasing, okay. Now just think about it. You guys are going to be data center engineers, right? Any virtual machine that is serving, let us say, 1,000 users, can the same amount of CPU, same amount of RAM, same amount of network, same amount of hard disk serve 10,000 users also? No, it's not possible. Okay? Physics. We can't change it. It's not possible. Right? Hence, what you should do, you should have more instances, right? But we see these virtual machines are very bulky. It takes time to boot. You have to install an operating system. That means you need to have license also. Then there is a cost implication to it. Okay? There is a lot of overhead, both from a management perspective, resource perspective, and cost perspective. Okay? So what do you think is happening in the back end? As and when the load on that application, as and when the number of users onto Hotstar, as and when the number of users onto Amazon are increasing, automatically in the back end, okay, the containers are spinning up, okay, automatically. And that same application, okay, is running across these containers, okay, and each individual user is being given a seamless access to that application, okay. And the moment the users log off, their job is done. T20 match is just for 3 hours or 4 hours at best, okay. After the match is over, all the users getting logged off. Why do I need to keep all those containers? Not required. Power them down, bring the resource usage down, okay. And all this happens automatically, no human intervention. No data center engineer is sitting in a seat and trying to spin up a container, okay, trying to allocate resources. No, nothing of that sort is happening. Everything is policy driven, everything is automated, okay. They understand that, okay, if 1,000 users log in, this is the number of containers and resources required. If 10,000 users log in, this is the number of containers and resources required. If a million users log in, this is the number of containers and users required. And all of that, they would have written policies in the backend. And as and when users are logging in, automatically containers get spinned up and they start serving data from the application layer. Okay. And this is the new world. Okay. This is the new world. That is the core difference between a virtual machine and a container. A container allows you to run code directly on it. No need of a compiler, no need of an operating system layer, no need of a hardware emulation layer. Okay, and these are very lightweight, just a few MBs. Whereas we saw that the virtual machines are pretty heavy, right? Hundreds of MBs, sometimes going into GBs also. Okay, so obviously they are very resource hungry, they take time, and that's the old way of running applications or workloads. Okay, any questions on conceptually what is a virtual machine and what is a container? I have very simplified it. Okay, as and when we learn more on how to utilize Proxmox, we will understand how to create virtual machine. We'll also understand how to create containers. Okay, and the GUI that you saw on the left hand side tab, Bhanu, can you go to that tab? The Proxmox tab. Yes. So now you understand those two buttons there on the top right hand side corner. When you click on create VM, okay, it will allow you to create a virtual machine. That means you will have to necessarily tell which operating system, how much CPU, how much RAM, how much hard disk space, and all. Okay. But when you click on the second button, create container, you will see that it will just allow you to create the container. It will not even ask, okay, what is the operating system required. Okay, and all of that can be managed through this GUI for Proxmox. Okay, clear? And then great, thank you. You will also see which user has logged in on the right hand side, and you will see the log or the tasks that are currently happening in the cluster down below. Okay, so you can see if a VM is getting created, what is the status? If a container is getting created, what is the status? If some error is there, what is the status? So for basic troubleshooting, you can just see the bottom lines there, and once you click on any line there, okay, just click on any line, Bhanu. On the right hand side, you see an arrow, a greater sign. Yes, okay. You will see more details about that particular task. Okay, and click on status, click on the status bar. Yes. So you will see more details when that activity started, when it ended, how much time it took, okay, what is the task ID, which user initiated it, what kind of an activity was it. You can effectively use this information to do basic troubleshooting. But again, as I said in the beginning of the class, I would recommend you do all of this through command line. The better you are in command line, the more weightage you will have with respect to your job. Okay, because you will find many people very comfortable with GUI, but not everyone is comfortable with command line, and hence the people who learn command line and are very good in command line are given more weightage with respect to a job. Even customers feel more comfortable when they see engineers working on command line, because then they understand that, oh, this guy or this girl knows what exactly they are doing, and they are considered better than the others. Okay. All right. Manu, thank you. Let us move to the virtual environment. Right. So here you see three tabs on the top. Bhanu, please put your mouse there. So we see a virtual machine called Windows Server 2022 on the top. Okay, so that's one virtual machine, not a container. Okay, it's a virtual machine. So just see the power of virtualization. You're having a desktop class operating system on the physical machine, but after installing a virtualization layer on top of it, you're able to run a server class operating system inside that virtual machine. Okay, so that's the layer of abstraction that virtualization creates. And this particular machine where we have Proxmox installed is being shown as other 64-bit. Okay, and then we also have our RHEL machine. Okay, Red Hat Linux Fedora Core 9, and then we also have a Windows 11 class operating system. Okay, now The first thing that we need to learn is how to log in and access these machines remotely. Okay, why do I specify the word remotely? Because not every time you will get physical access into a data center. Okay, and some people who have worked inside data centers, they know that it takes a huge amount of time just to get inside a data center because of all the physical security norms. Okay, hence you need to first understand how to remotely log in to these machines. Okay, the most popular tool that is used to do that is called as putty. 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 Okay, so go to any browser. Can you go to a browser, Manu? Yeah, and just type download putty. Download putty. Putty. Yeah, press enter. The very first thing that you get, that's the one. Okay, it's a free tool. Okay, no need to
Sir,
be
it's
paid.
already installed in my laptop.
Sure, sure. Just, but let us show everyone where
Ah,
to download it from. So you will go to a website called putty.org. Okay, and you will find various versions of putty. Putty that can be installed on Windows, putty that can be installed on other operating systems. So you will see that. Now, basically, what exactly is putty? Okay, as you can see here, it's a terminal client. All right, it's a terminal client, and the person Simon Tatham, he is the one who originally developed it. It allows us to remotely connect to a machine. As long as there is network connectivity, you don't need a keyboard and a mouse to be attached to that physical machine. You can use putty on your laptop, and you can use putty to remotely connect to that machine. Okay, so let us show you how to do that. So once you download putty on your machine, a normal exe file is downloaded. Yes, you see there. So if it is for Windows, you will see the putty installer for as a .msi file. MSI stands for Microsoft Installer. And you have various versions, 64-bit and you have 32-bit. Okay, 32-bit obviously are for the older operating systems. 64-bit are for the latest operating systems. And within 64-bit, you will have the two versions. One is for Intel based. So whenever you see x86, that is Intel based chipset. And whenever you see ARM, that is with AMD chipset, AMD processor. Okay, so depending upon the machine that you are using, whether it is Intel based or AMD based processor, you have to download that version and install it on your machine. Okay, once you install it, yeah, you can just double click it and it will install. Okay, yeah, click on next. We'll not complete it because it's already installed. You choose the path where you're going to install putty. Click on next, and then just normal where do you want to keep the shortcut and everything. And once you click on install, it will get installed. Okay, so since it's already installed on this machine, we'll just go ahead and skip this last part and open the putty console. So once putty is installed, you will see this kind of an icon, and this is the GUI for putty. Okay, all of you can see this. Okay, now don't get too bogged down by the various options that you're seeing here. Okay, As and when you use this, you will get very comfortable with it. It's a very simple, but at the same time, very powerful tool. Okay. And as and when we use it, I will show you various options of using the advanced features of this tool. As of now, we will use the basic features. Okay. Now, what are the basic features that we are going to use? We are going to use that connection type. You see the connection type below the IP address bar. It allows us to connect to any machine using any one of these protocols. Okay, using any one of these modes. Okay, the most popular mode is SSH. The most popular mode is SSH. Okay, what does SSH stand for? Can anybody tell me what does SSH stand for? Google it, no problem.
Single sign post.
Sorry.
Single
Secure
sign
shell.
close.
Secure shell.
Okay, Anand, Hari, you're right. Samsivrao, no. SSH stands for secure shell. Okay. And in our previous classes, we understood what is a shell, right? So what shell were we using all this while in our class? Can anybody tell me? Which shell were we using?
Bash shell.
Bash.
Yes, correct. Bash. 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 Okay. And what does bash stand for? BASH stands for?
Burn again shell.
Yes, correct. Born again shell. Not BORN born,
You are
BOURNE.
can.
Yes, born again shell. Okay. But that bash shell is something that you access once you are inside that machine, once you're able to log into that machine. Okay. And this putty tool allows you to remotely log in to a machine using a protocol called as SSH. Okay. Secure Shell Protocol. All you have to do is enter the IP address or host name in that box, text box, and it will allow you to get connected as long as you have the credentials with you. Okay. Now, uh, uh, yesterday we learned one thing, right? What is the entity in a network which translates a host name to an IP address?
DNS.
Yes, correct. DNS. So in our environment now, in this lab that we have created, do we have any DNS server? Have you spoken about a DNS server? Have you installed any?
No.
No, correct. So is it, will this putty work if I enter a host name to
I
access the
guess no, sir.
Proxmox VM? No, it will not work. Correct. So what we have to do, we have to enter the IP address. Okay. Right? Now, we will show one by one how to enter the IP address of each of the machines and how to get access to it. Okay. So, first we'll go to the Linux machine. So, Bhanu, can you go to the Linux VM?
Red
Yes.
Hat, sir.
Yes, Red Hat Linux. Please log in. Note the user ID here. The user ID is admin. But when we do in putty, we will generally for Unix try to use root unless any other user has been created. Okay. Go to terminal in the bottom. Yes. Terminal will allow you to create the or access the CLI. Yeah. So, yeah. And can you zoom a little bit to increase the font size? No, no. Internal. Yeah. 20. Close this. Great. Okay. So, can anybody tell me what is the command to understand what is the IP address of this machine?
IP config.
No, you are
No.
getting confused between
IF.
Windows and Linux. Yes,
Oh,
Anand, correct.
yeah.
Yesterday we have learned this, right? IP config is in Windows.
Yeah.
In Unix or Linux, it is IF config.
IF.
Okay. What does IF stand for? What does IF stand for in Unix or Linux? Interface. Okay. IF stands for interface. That's why the command name is interface config. Okay. Now let us understand the output here. The first uh, thing that you see on the top after the command output has come, ENS160. Okay, ENS160. Manu, can you highlight that, please? ENS160, just select that. Yes, so that is the interface name. Okay, that is the interface name. What is that interface? Interface is nothing but a name given to the hardware network port. Okay, and it is using this name that the operating system identifies that particular device. Okay, and all the device drivers and all at the operating system layer are associated with this particular name that you see as an output in the command of ifconfig. Okay, and where do we have all these device drivers? In slash etc, one of the folders in slash etc. Okay, you will find for each and every device, there will be a device driver, and those device drivers will be associated with these device names. In case of a network device, the name is called as an interface. And what you see here, ENS160, is the name of the networking interface to which the IP address has been associated with. Okay. And how will we know what is the IP address? It is there in the output. You see inet, the 4 octets, okay, written next to inet. Okay, that's the IP address. Okay, I is internet network. Okay, internet network IP address. So that 4 octets after the word inet, that's the IP address of this interface. And this is the IP address we will need to put in putty to get connected to this machine. Okay. There are other aspects of an IP address also. Subnet mask, broadcast. We'll talk about it later when we are doing our networking classes. Okay. But for now, to keep it simple, we will use this particular IP address that is coming as an output from the ifconfig command. Okay. Which is the interface is ENS160, and the IP address is what you see on the screen here. Okay. Whatever are the other parameters, we'll learn about it later in our networking class. All right. Now, Banu, type one more command here called ifconfig -a space -a space -a. Enter. Okay. So there could be some hidden interfaces which are not exposed to all users on that machine. When you put -a, it's nothing but all, okay, all interfaces, it will show. So in this machine, the normal ifconfig command output and ifconfig -a command output are the same. That means there are no other hidden interfaces. This is it. Okay. Yesterday, you have also understood about this specific IP address reserved for something. Okay. Can anybody tell me what is this 127.0.0.1? What we learned in yesterday's class?
Class
127.0.0.1. Yes, Venkatramana?
class one of the class time.
No. This is a reserved IP. This specific
Localhost.
reserved IP. Yes, it's
Right.
called localhost. Yes. Right, Mahesh? It's called localhost. Okay. What is this localhost? Whenever any software or program has to refer to the same machine, okay, instead of giving that IP address of the interface, they can simply give this reserved IP address called 127.0.0.1, or otherwise termed as loopback IP, or also termed as local host. Okay. This IP cannot be given to any machine in the network. It is reserved for every machine. This IP is for localhost or loopback. Okay. This IP is used by any program running on the machine to refer to itself. Okay. When you want to refer it to itself, it will use this particular IP address called 127.0.0.1. Okay. It is reserved at the operating system layer. No other machine can use this IP, and every machine will have this IP associated for it, reserved to represent itself within its operating system environment. Okay, right. Now let us go to Putty. Let us go to Putty. Yes. Manu, can you type the IP address of this Linux machine?
Well, one doubt, sir.
Yes, Ramana. Tell me, Venkat Ramana.
In Windows also we have loopback address. No,
Yes,
right?
yes, yes, we do. Yes, I will show you. So, Bhanu, can you open command prompt on your Windows laptop? Yes. Now in Windows, you type ipconfig -a.
Slash
Slash
all.
all, sorry, slash all. Ipconfig slash all. Space slash all. Go up. Go up. Okay, it's not explicitly showing, but it is there in Windows also. So this is a networking concept. It has got nothing to do with whether an operating system has it or not. It will be there. Okay.
Okay.
So the proof of it, I will show you. So come down, Banu, in the command prompt, just type ping space 127.0.0.1. See, you're getting the ping. That means that IP address is configured and it is there already in the operating system. Okay.
Okay.
Yeah. So every OS will have this reserved IP. Okay. It's a standard. It's a standard in the industry. All right. Let's go back to Putty. Yes. Please type in the IP address of the Linux machine. Yes, SSH. And one second, one second. In the left-hand side window, go to Appearance. Go to Appearance. And yeah, click on Change Font and increase the font size to 20. Yes. Click on Open and accept. See, give the root username and give the password. See, so using Putty, as long as you have network connectivity, okay, from anywhere in the world, you can log into any machine, okay, with your laptop. And this is the thing that is used everywhere, okay. Now give the same ifconfig command here. See, we are getting the same output. That means we are logged into the same machine, right? Clear? Any doubts? Now let us exit this. Okay. Let us try to log into our Proxmox machine. So, Bhanu, can you go to the Proxmox machine? Okay. No, this is the Red Hat one. Yes, this is the Proxmox one. So type the ifconfig command here. Here it is IP space A. Okay. Now here we see, can you scroll up a little bit?
It's not open.
Okay. So here we see, there are multiple interfaces. There are three interfaces actually. The first interface, LO, is the loopback or localhost 127.0.0.1, what we saw just now. Then we have ENS32 as a second interface. Okay, no IP is assigned to it. That's why there is nothing that we see there. Okay, and then we have the third interface, VMBR0. Okay, and the IP 192.168.1.55 has been assigned to it, and we see it there, right? And now we will try to use PuTTY to get connected to this particular IP address. Yeah, exit, open PuTTY again. Root, and then the password. You immediately see the IP address also there, and it's logged in. See, we are logged into that. Give the same ifconfig command here. Sorry, IP space A. IP space A. I'm so sorry. Proxmox is a little different. Yeah, we get the same output. So this is the first thing that you have to learn. So you can use PuTTY to remotely log into any machine from your laptop or desktop. Okay. So from now on, what we will do is we will use only PuTTY. We will not use the direct login into the machine. Okay. And now we start doing certain activities on these machines to learn more about our Linux concepts. Okay. So the first thing that we are going to learn today for the rest of the time that we have is how to check for connectivity options, okay, from one machine to another machine, and how can we troubleshoot certain aspects about it. So we will start with Bhanu, just reduce the size of this window and open one more PuTTY session and log into the Linux machine parallelly. So you can right click on the bar and say new session. A new PuTTY session can start. So you can have as many PuTTY sessions running parallelly from the same laptop to as many different machines, or even to the same machine also. Okay, you can do multiple PuTTY logins through different users to the same machine. You can do that as well. Okay, so put them side to side, Bhanu. Great. So yes. So the machine that we see on the left, where we have the IP 192.168.1.55, that's the Proxmox Linux VM. And the one that we have on the right, where we have root at localhost, that's our Red Hat Linux machine. Okay. And we know the IP address of each other. Now I want to check whether the Proxmox machine is reachable from the Linux machine or not. Okay. So yesterday we were trying to learn this, right? So what is the command to check whether another machine in the same network or a different network is reachable on the network or not?
B.
Yes. So on the Linux machine, Bhanu, try to ping the Proxmox machine, ping space 192.168.1.55. Simple. And we are getting a reply, which means it's pingable. Great. Control C to break the loop. Yes. Same thing, you type on this machine, ping space, you give this machine's IP address 192.168.1.7. Okay. And you're getting a response. So it's working. Great. Control C. All right. Now, if I want to understand the network route it is taking, okay, to go from your machine to that machine, okay, then what is the command I will use and why this is needed? Why this is needed is I will tell you. Especially when some user complains, Array, my machine is slow. I am not able to see the website. It is taking lot of time to load. Okay. Some of your friends who might be doing website development, they might be getting these sort of complaints from their customers. Okay. So what is the first thing that you will check? The first thing that you will check is what is the time it is taking to reach that machine from the network. Okay. And ping allows you to get a brief idea about the time taken. How? You see the output of the ping command, right? So it is when you see the output from the right hand side window from the Linux machine, can you highlight one output? Yes. So it says 64 bytes packet is being sent from this machine to the destination machine 192.168.1.55. Okay. And it is using something called as a protocol called ICMP. So the ping command actually uses a protocol called ICMP in the backend. Okay. And it is giving the sequence number. So I'm sending the first packet, then the second packet, then the third packet, then the fourth packet, and so on and so forth, right? And we saw that we were able to send some, uh, you know, 7 different packets to it, all right? And then we have something called as TTL, okay? That is nothing but the 64 bytes, okay? And then we see the most important parameter, which is called as time, all right? Do you see the same time in every sequence and output? You see the time there? The first sequence was 1.16 milliseconds. The second one was 0.56 milliseconds. Third one was 0.99. Okay. So it's not consistent and it never will be. Okay. It never will be. You will not see the same thing. Okay. Why? Why is this? Can anybody take a guess? Why? Let me explain. Okay. Very simple. In our homes, we have taps, okay, and we have an overhead water tank, right? The tap which is there at the kitchen sink when you open it versus the tap that you have, let us say, in your wash basin, okay? Do you always see the same kind of water flow and output from both of them, even though it is coming from the same water overhead tank?
No, sir.
No, obviously not. Why? There are so many different factors, right? What are these factors? What is the length of the pipe? What is the diameter of the pipe? What is the diameter of the tap? How much have you opened the faucet? Okay, which means there are so many variables which decide, okay, the amount of water flow from the same source to a slightly different destination, right? Exactly the same way in networking also, even though the source and destination may be the same, there are so many variables in between that always the same size packet will not take the same time to reach the destination. Okay, there is so much amount of traffic in between. Okay, and because of the traffic in between the source and the destination, always the response or the time taken for the packet to travel from the same source, same size packet to the same destination is probably never going to be the same. Okay, it is probably never going to be the same, and hence this is the first indication that you have to check when anybody complains about slowness, okay, of accessing a machine, or slowness saying that, array, my application is not working. First, ping it. Ping gives you two kinds of output. One, whether it is reachable in the first place or not. And second, if it is reachable, what is the delay from that source to that destination? And generally that delay is measured in milliseconds. Okay, and if you see a huge amount of difference, okay, in that time taken to get a response from the destination, then you understand that, oh, there is some issue with the network part of it. Okay, and we will have to start troubleshooting it. Okay, so let me give you one more example. Bhanu, in the same window, type ping space www.google.com. Enter. Okay, do you see this difference? Can you highlight that output, please? Google.com is on the internet, correct? Where is the response coming from? Its response is coming from an IP address called 142.250.183.64. God knows where that server is. Okay, or where, on which interface that IP is configured, we don't know physically. Okay, do you see the time taken? Now it is in tens of milliseconds. Within the local area network, when we are pinging from a source to a destination which is there in the same network, okay, we are getting the response in less than 1 millisecond. But when we are going outside the network, when we are going to WAN, okay, obviously the response time is increasing substantially, right? And it has increased by tenfold, 10 times. Okay, earlier it was less than 1 millisecond. Now you are getting 10 milliseconds, 11 milliseconds, so on and so forth. Okay, and this is what is going to happen. This is what is going to happen predominantly. Now, how to understand what route the packet is taking, okay, to see whether it is taking a simple route or whether it is taking a very complicated route, okay. So we can get to the next command. So can anybody tell me what is the command in Linux or Unix to understand what is the route, network route a packet is taking to go from one source to a particular destination? Google it, no problem.
Trace.
Trace route, not just trace, trace route. Correct.
Trace route.
That's the command. Yes, trace route. Okay. So, Bhanu, please type that command. Single word, space. First,
RTI.
let us do trace route to the machine that's there in our local network, which is 192.168.1.55. Yes. Press enter. Trace RT. In Linux, it is trace RT. Yeah. In Windows, it is trace route. Yes.
Same sir, trace RT only.
Hmm? Try trace R. Mhm. This, why this command is not there? Okay, try it in Proxmox. Trace route is there. Yes, use trace route space. Give this Linux machines. Mhm. Yeah, you see the output. Okay, so it says 192.168.1.7 is the destination. Okay, maximum 30 hops is what it's going to check for. Hop. Now, what exactly is a hop? A hop is a jump from one network to another network to reach the destination. Okay. In our case, there's just one hop, and hence we see only one output. Can you highlight that one? The output that is coming from one. Yes. Okay. And it says that within one hop, it is able to reach its destination. Okay. Within 1.195 milliseconds, right? Now, the same thing, let us do trace route to www.google.com. Spelling wrong. Right. Now you see how many hops. See, still going on. Within 30 hops also, it was not able to reach. Okay. See, this is what is happening in the backend. All of us are so used to typing www.google.com in the browser, but this is what is happening in the backend. Okay, so that request has to go from the NIC card or interface of your machine all the way to the server, okay, where Google is hosted. And now, do you see the IP address change? The first, no, even before that, trace route to www.google.com is now referring to a different IP. It's no longer referring to the other IP that we see on the right hand side window. Can you see that? In the right hand side window, the IP was 142.250.183.64 on top. Okay, when we did a ping to www.google.com, okay, it returned an IP this. But now the same URL, the same, did we change the URL? No. Okay, we only change the source machine www, but we are going to the same URL www.google.com, but now it is returning a different IP. Okay, how is that possible? Okay, how is that possible? That the same URL is mapped to different IPs in the backend. Okay, that is called CDN, Content Delivery Network. We will talk about it later when we are doing our networking class. Okay, so most public URLs are not mapped to a single machine in the backend. Okay, Google has thousands of servers across the globe, right? So how can all the servers have the same IP? It's not possible. Okay. So each server will have its own IP, but to the end user like us, it will be a common URL www.google.com. So something in the backend has to do this address translation. Okay. So that is primarily done by an entity called a CDN, Cloud Delivery Network. Okay. Sorry, Content Delivery Network. Content Delivery Network. Okay. CDN. So that CDN layer comes in and it allows any public facing URL to be mapped to multiple servers in the backend across the globe. Okay. The most two common CDN providers in the world are Akamai and Cloudflare. Okay, Akamai, 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 and Cloudflare. Okay, CLOUD, cloud, FLARE, flare, but single word, Cloudflare. These are CDN, content delivery network providers. So any company which is developing, let us say, a SaaS platform, okay, or even a web application to be hosted on Google Play Store or Android App Store, okay, they necessarily have to use a CDN layer below it to ensure that whenever a user is trying to access their application either through a browser or through an app, okay, in the backend, that will spread across and load balance across multiple servers in the backend. So in the networking layer, this Cloudflare or Akamai is used. Okay, there are many other CDN players also, but these two are the most popular. Okay, so we will not go into the depths of it right now. We are still in the simple phases. But this is a very useful way to understand if there is a delay in the network. Okay. So the expectation from the customer is that whenever you are pinging anything within the network, okay, within their LAN, all right, if they are in the same network, it should happen well below a single millisecond. But the moment you are going to, outside world, the internet, 10 milliseconds, 20 milliseconds, 50 milliseconds is acceptable. It's okay, right? But not beyond that, not 100, 200, 300 milliseconds or even 1 second. That's slow. Okay. In today's world, that is slow. So this trace route and ping together will give you an idea, okay, whether there is any bottleneck at this layer or not. Okay. Right now, I'm showing you a manual way of doing it. Later, when we get into our Zabbix class, where we are going to learn about NMS platform, Network Monitoring System platform, there we are going to see how to do this automatically. Okay. And in the GUI, no need to keep typing commands and all that. All right. So for now, this is what we have learned. If there is any network delay, the easiest way to find is one, to do a ping, and second is to do something called as a trace route. Okay. It can be to an internal IP address or it can be to an external IP address also. No problem. And trace route will also accept host names. Okay. As long as that host name is being able to resolve. All right. Now, I want to copy some file. Okay, I think we are running out of time. So that those operations we will do tomorrow. Okay, we will show how to start interacting, moving content from one machine to another, and in that process, learning more and more concepts. About Linux, different commands. Okay, so that the learning is not theoretical; it is actually practical and use case based. Okay, so we will learn about that. Before we leave today, once again, a general reminder about the test and evaluation that we are going to have on the data center concepts, okay, which we have learned earlier. Those recordings are available in YouTube. Please do spend some time, go through them, okay, so that you do well in the test, okay. There will not be any supplies, okay. There will not be any retakes. So prepare well, and I will be asking certain trick questions also, and all the answers you will be giving through an app, okay, not orally like this as we are doing in the class today, or as we keep doing in our classes. So you have to record your answer through an app. We will use the Kahoot app to run this evaluation and test. Okay, so prepare well, and we will have it on Saturday. We will have our evaluation or test on Saturday morning. Okay, so prepare well. In the meanwhile, in the previous classes, in the data center basic concept classes, or in these Linux classes, if you have any questions, any doubts, please feel free to put in the WhatsApp group. We will be more than happy to help you with the answers for it. Okay. So just a quick recap of what we have learned today. We have seen the GUI of Proxmox, how it looks like. Okay. We have understood the basic architectural difference between what is a virtual machine versus what is a container. Then we have understood the tool called Putty, how to use Putty to remotely log in to any machine. And then we started using Putty parallelly. We have logged into two different machines and we are starting to use these Putty tool to run commands on our backend Linux and Unix machines. Okay. And we started with basic networking related commands, if config, IP config. Then we learnt about ping, how to analyze the output of the command ping. Then we saw what is the difference between pinging to a local network device, pinging to an external entity. We saw the difference. And then we also identified one more command called traceroute, and using traceroute, how to understand how many hops a network packet is taking to reach its destination. And we also briefly touched upon the concept called CDN, Content Delivery Network, which allows any public facing URL or app to be distributed across multiple servers and multiple data centers across the globe. Okay. And the most popular content delivery network providers, CDN providers, are Akamai and Cloudflare. Okay. All right. Thank you so much, boys and girls, for your time today. We will meet again tomorrow. Once again, prepare well for the test coming up this weekend. 3 more days to go. Thank you. Have a nice day. Bye bye.